All right, so in this video, we're going to be talking about spatial compounding and what the advantages of using spatial compounding over general B-mode imaging would be. With spatial compounding, a large portion of our image is basically lost due to noise, speckle, artifact. Basically, the machine not understanding the signals that it's receiving back, if they are true or if they are an artifact. Our contrast is affected because rather than having sharp borders, we have multiple levels of gray speckle throughout that kind of muddy the borders of organs, of masses, of vessels, especially cysts, able to resolve certain things. A lot of what we talk about when we talk about this speckle is something that's created by constructive and destructive interference of waves, and we'll actually talk about that here in a second. The thing is, this graininess is basically a characteristic that most people tie to an ultrasound image. When you ask somebody, oh, you know, look at this ultrasound image, oh, I don't know what that is. Basically, all they see is the grain. So let's look at what this means. So if we have a wave coming off, you know, the wave comes out, and then it hits a structure. There'll be a little structure here. Well, it's going to send a reflection back. But as the wave is still coming at us, every point that those waves intersect, the returning wave and the coming wave, those points will create other waves. Those will create more ripples that head off in all directions. Well, those little points are what we see as speckle in our machine, because the machine is receiving the sound, and it's taking a certain amount of time to receive it, so it thinks, oh, I must place a dot there. So the machine gets confused by these waves that it's receiving that it actually didn't send. So if we have a wave and it meets another wave, a couple things can happen. It can either add together and basically create a bigger wave. And so the machine thinks, oh, here's this big wave coming back, so it puts a bright dot on the screen. Or we could have a wave and another wave that are kind of out of phase, and basically they'll cancel each other out. So where there should have been a dot, there won't be a dot placed. And the machine just doesn't know what to place there. So this is how we can lose pieces of our image, either by not receiving a wave that we should have, or by receiving too many waves back that the machine just doesn't understand what they are. So let's look at what that kind of looks like here. So if we just take a general B-mode image, let's draw out our transducer here. So lifelike. It's incredible. So here's our image. And basically only one angle of insonation. That's a general B-mode. It just sends from one direction. And as that wave hits different objects, well, it'll send reflections back. But those reflections go in every direction. Well, those waves are going to interfere with each other and send new waves back. And the machine only knows one direction, so it only knows one thing. So it's expecting waves to come back. We also have harmonics that come off the bottom, you know, from the back, and those will interfere. And every time any wave intersects with another wave, it's going to create a different wave. Smaller, but different. The machine just doesn't understand how to handle that, so it places a dot for every single wave. So let's look at our compound image. We have our transducer, and the difference with this transducer compared to B-mode is we have multiple angles of insonation. So it sends waves off in multiple angles, and when it sees it come back, so we have our three different angles, and really there's many. It actually sends beams off in each of those. Well, if we have a structure that's sitting back there, and the machine receives an echo from both the first angle of insonation and the second angle of insonation, it can assume that something belongs there. So it'll actually place that dot. But if it only receives it from one angle and not the other one, then it's assuming that's noise. So this will reduce the speckle. And it's not that the machine is not placing the dot. what it's doing is it's creating 3 different images and overlaying them on top of each other. And through that, like, superimposition, it removes a lot of the speckle and a lot of the noise. So with our compound image compared to our B mode image, this is what can happen. Let's look at if we have a mass here. So let's draw out a liver here. Just imagine you're looking at a liver here on a generous patient. That liver's kind of way back there. So we have our mass here. And on general, with B mode imaging, that single angle of inclination will probably create shadows on the edge of that mass. So if you have that shadow, that may be hiding information. So imagine we have another smaller mass hiding back in there where that shadow is. With just B mode, general B mode, one angle of inclination, we won't see that. But with the compound image, what can happen is we can look in multiple angles and basically look around the corner of that mass and see what's hiding back there. So the compound image can reduce that shadow artifact. So if you look at the image here on the left, this is just traditional B mode, lots of speckle, lots of grain. The center of the image is dark, but that's about all you can see. On the right, you can see that this is a compound image. This is just in a phantom with an irregular bordered mass, but you can see how it removes much of the speckle and the grain, and you can actually see pretty definite borders on a pretty irregular mass. So that's the benefit we see of compound imaging. The downside is, of course, your frame rate's going to go down. The image does look really smooth, so you lose a lot of that really crisp, like the crispness of the image. But the benefit is just so much better. This is used a lot for, let's say, like breast and soft tissue masses, really helps. But just in looking in like a liver as well, you can notice a difference. Next time you're scanning and you have something, just try messing with the setting and see what it does. So anytime we talk about spatial compounding, I want you to think of a few things. I want you to think about the angle of inclination. I want you to think about reducing speckle and reducing noise. If you keep those things in mind, anytime there's a question, it should be pretty easy to answer the question. All right, so hope that helps. Take care.